I have the distinct pleasure of kind of introducing what's new as part of our latest release, and also a bit of a recap and what was kind of made available in 2.2.0. A lot of this stuff will be extremely new for folks, but also for some folks there might be improvements as well over what you're used to experiencing with CSX and Cerebras in general. So what I'll do is kind of walk through everything. If at any point folks have any questions, feel free to, there's multiple different ways, feel free to just call out because I might not see the chat or post a message in the chat. I know the team from Cerebras is also monitoring that. So let's make this interactive. If you have any questions or comments, we can definitely answer them in line. All right, we have about half an hour. Okay. So the overall kind of thrust of the presentation is going to be to discuss what's new with respect to our reference implementations. There's a bunch of new models, a bunch of new implementations in all types of shapes and sizes. Multimodality, of course, is going to be a big theme of today's presentation here. We'll also talk a little bit about some changes to our model zoo, right? What's the organization and some performance things following that. And lastly, we will end with some workflow features that we're releasing as part of 2.2.1 that as you guys upgrade. The release just came out this week. So it's an exciting time to kind of get familiarized with the system in general. As you're getting familiar with 2.2.0, you can look to these features as they drop in 2.2.1. All right. And I see there's a couple of questions already. But okay, I think it's regarding the previous section that Bill went through. Okay, great. So one of the big things that we're very excited about with 2.2.1, and it's been mentioned a couple of times, is the full support for multimodality with this release. And specifically, we're looking at visual Q&A. And the first model that you'll be able to experience that with is going to be the Lava visual instruction tuning model that's combines text and images. So with 2.2.1, we do have now support for multimodal models. And as I mentioned, it's specifically VQA. And today you'll be able to use these models for reasoning across text and images, right? So we're talking about things like charts, graphs, and other standard images. Today, you can also use pre-trained image encoders, so we can think about things like CLIP, the contrastive loss image encoders, VIT, the visual transformers, right? As long as they're pre-trained, you'll be able to use them, train a cross projection layer, and train a LLM. Of course, you can pre-train LLMs using Model Zoo today. You combine all that and put together Lava. We do provide reference implementations for Lava today. Pre-training of image encoders is something we are planning on providing support for in our next release, together with enhanced support for other modalities. And then looking forward, we are going to be expanding support for things like video, audio, IMU motion data, right? Multiple modalities going forward. Today, of course, it is in the realm of text and images. Now, I do have something I want to share here. And of course, if you're looking to learn more, these slides will become available to you after the presentation, and you'll be able to kind of click through and look at all the reference implementations, the documentation. Do not be shy about going through all that and digging through as you're exploring. One thing I do want to kind of share with you is a quick demonstration of what this visual question answering model can do live. So let's take a video, and then I was able to get access to an instance where I can actually show you some live questions, which is being powered by Lava in the back end. So in this example, what we're going to see is, of course, it's a visual question answering model, right? It's Lava. So we've got an image, and we've gotten a sort of a question. Those are typically the formats in Lava models. It's image and caption, or image and question. And that's what we're seeing here. It's an image of a couple of pennies, and it's just a couple of different monetary value coins. And we've asked, can you tell me what all the coins are here, and we'll see what the assistant comes back with. So as you can see, it's kind of streaming the responses here. It says the coins in the image include a penny, a nickel, a dime, and a quarter. So it's able to understand what is actually in the image as a description. But what's more interesting is the subsequent question where we then ask, how much are they worth, right? So it's not just describing what's in an image, it's also then able to do subsequent reasoning over that, right? So here it's coming back and saying it's worth, 1 cent, the nickel, 5, and the dime is 10. And of course, the quarter is 25, right? So in addition to just descriptions, the Lava model is capable of doing some really interesting things like reasoning. Now, let's quickly switch gears here. And let me actually show you this in action. This is kind of an in-house demo that we've put together. And I was able to get access for today's presentation. So let's do a few examples here. We have a built-in example that we can do. This is an interesting image of a person riding on the back of a car, and they're ironing their t-shirt. And we can ask, what is unusual about this image to the model? See what it says. And here you can see, again, this is kind of happening live. We can see that the assistant comes back and says the unusual aspect is that this man is ironing clothes, right? This is not a typical scene. And it's not common to see someone doing this activity, traveling in a vehicle. And of course, it's an unexpected visual scenario. So very interesting. These are the types of images that the system has been trained on. And what we can do, and this is something that's now possible because we have reference implementations, is you can push this to fine tune it to specific domains. Now, we'll show you an example of maybe a research scientific literature. Here, what I'm doing is I'm uploading, we can take a look at this picture, just a simple graph of the counts or the amount of a certain molecule that's present in some volume, and then it's decreasing over time. And we can go ahead and pop this image in, and we can say, what is this molecule? And it's able to kind of understand this. It's able to provide an answer and tell us what it is, that it's fluorescent, which is a type of fluorescent dye, right? So it's able to understand rudimentary things about this image. But if we were to push it and ask it more details, these are areas where there might be some gaps. And this is an incredible opportunity, right, for someone at ANL to then go in, fine tune this Lava model with continuous sort of training and fine tuning to a specific domain. Different domains are, you can kind of continue this in any domain and get much more robust answers for a particular variety of images and specific domains. So that's one example I wanted to show you. I do have another fun example here where we can go ahead and clear this. And you can see I have pretty long hair. I used to have very short hair. So we're going to pop in a picture of me. We're going to say, what is he doing? And it's going to come back and say the man is smiling and looking off to the side, possibly at someone, something, or someone. We can ask follow-up questions. What do you think of his tie? Man's tie is described as very nice. Well, that's very kind, which suggests that it's well coordinated with his suit and adds a touch of style to his overall appearance, right? So it's able to reason, it's able to have sometimes amusing responses to questions that we ask it about images that we provide. Okay, great. So that's now available in Model Zoo. You can go check out, again, in the previous slide here, you can check out the reference implementations in both 13 billion as well, 1.5, 13 billion, and I believe 1.6 is going to be available soon as well, but 1.5 is certainly available as a reference implementation today. All right, the next thing on the docket, of course, everyone's most likely heard of Llama 3, the latest release from Meta, and how it vastly outperforms Llama 2. And this is very interesting. Our team, the weekend that it was released, kind of went through, grabbed a couple of checkpoints, validated that it would work on our system, and over the weekend was able to release reference implementations. in both 8 billion as well as the 70 billion variants. So reference implementations as well as the config parameter files, the same files that you saw Bill manipulating in his demo, those are now available in Model Zoo as part of 2.2.1. Now, there's a couple of key takeaways here that I want to sort of highlight, right? If we look at the differences between Llama 3 and Llama 2, what are they, right? One is that there's longer context in Llama 3, right? They went from 4K to 8K. There's maybe a larger vocabulary, right? 32,000 to 128K. And then there's a new style of attention, a grouped query attention that's now available as part of Llama 3. And then, of course, it's been scaled out in terms of the training. So what this tells us is if we're able to do this over the weekend, that you're able to do this now that you have access, after today, now that you understand how to get access to the systems, you can easily take a config file, quickly update a few parameters, quickly update maybe the attention blocks, and go ahead and train the next Llama. You don't need to wait for Llama 4 to come out from Meta to be able to do this. We can actually start experimenting today and build our own Llama 10 if we wanted to. That's why it's exciting to kind of see this progress and realize that the support for LLMs within our platform here is very robust. And that's now, again, as I mentioned, available in the Model Zoo repository, all of the config files, as well as the reference implementations. And this link, if you click on it, will lead you to a README that you can check out for more information as well. Okay. Excellent. Now, the other thing that we want to talk about in the model section is support for two additional techniques, right, with DPO as well as the next one, which is going to be with DPR. The important thing to note here is that DPO is a form of alignment technique, right? So when we typically train LLMs, this is probably familiar to most folks. You have an LLM that's simply generating text after text, token after token. It's a generative model. But in order for it to align itself to that it should answer questions or that it should summarize text, right? These are not implicit tasks that it's been trained for. It's just been trained to output the next token. We use things like RLHF and other techniques to align the model, A, to human preferences, but B, to the specific task or the format of output that we require. Now, the problem with RLHF is that it's very unstable because of the reinforcement learning component there. DPO is a new technique that's much more stable, performant, and lightweight, and it's also very simple to train. Instead of reinforcement learning, direct preference optimization, as you can see in this image, typically just uses classification loss and directly trains on the preference data. All this to say that it's a much easier model to align large language models with. Again, reference implementations for this are now available in 2.2.1, as well as the config files, and you can click here for more details to go around and play with that and see what you can do with it. All right, last but not least, in models, I do want to mention support for a new RAG-based technique that's actually been around a while, but now we have full-fledged support for this as part of our Model Zoo reference implementations, is the model known as DPR, dense passage retrieval. Now, I think this is going to be familiar for most folks, but RAG is the concept of in-context learning or in-context response generation, where you have a model that's going to reference information that it has in the moment that's been provided to it by a user, maybe in the form of documents, or provided to it as part of the prompt generation process. It can access things like company manuals or product manuals and be able to answer questions about those documents. And the key technique here in DPR, in dense passage retrieval, is that we separately encode the question, we separately encode the passage or it's also called the context, and then we train these encoders together using contrastive loss. The goal being to make questions and answers that are similar. The embeddings for those will be closer in nature, and the question and answer pairs that are dissimilar, those are going to be further apart in this high-dimensional embedding space. All this to say, again, that the reference implementation for DPR is now available in Model Zoo, and we're excited to see what you can do with it. As well, the config parameter files are also there for you to play around with and tweak and experiment. Great. All right, so moving on to our Model Zoo features that are sort of new in 2.2.1. Actually, before I do that, any questions about the models that we now have, how you might use these? Has that all been fairly clear? It should be based on kind of Bill's presentation as well as some of the other things we talked about so far, but any questions about the models that we have in 2.2.1? Okay, excellent. All right, so let's talk a little bit about what's new in Model Zoo itself. So the way to configure models, as you've seen today, kind of throughout, is to use these configuration files or params.yaml files. With 2.2.1, the way to actually manipulate these files does not change. You still kind of configure things using, let's say you want to train the new Lava model, or you want to train something with DPR or DPO. You can still configure things in the config files. But what's now interesting is in the back end, we now have everything backed by what's known as these configuration classes, these config classes. And what these provide is a couple of really interesting benefits. In the back end, we have the ability to validate things that you're providing in the configuration file. This includes things like bounds checking on values, type checking, is it an int, is it a bool, and then enforcing cross-configuration compatibility. If you set a parameter to X, does some other parameter then need to be Y in order for the model to train properly? Right, so all of this today has to be managed by the user, by the researcher. We have to go in, we have to make sure that all of the configurations make sense, that they're the right type. Config classes allows us to do this automatically. For all the models that you see in Model Zoo, it'll be backed by a config class. It'll have its own validation checking. And then the additional benefit of providing config classes is that now for each configuration, each parameter, of which there's quite a few that you can tweak, a lot of knobs that you can modify as you're training these models, they all have documentation now because of doc strings that we can provide in the Python class implementations for each of these classes. So to kind of ground this a little bit, what you're seeing on your screen here is just sort of the inheritance model for these config classes, right? So there's a base config class. We might have a config for data, for the optimizer, for the run config. You've seen this a little bit today. For the model config. And then if you dig into what a model config might look like, for GPT-2, we're going to define our own model config class. Similarly, for some of the new models that you saw today, for Lava, for Mistral, MPT, Llama, they'll all have their own config class. In addition to the config YAMLs that you can modify, you can also then dig into the config class to see how it's structured. And if you're going to bring up your own models in the future, you can also provide a config class for that, again, to provide this type of bounds checking and type checking. Here's what it looks like in the back end when you actually go through this. So for example, let's say you have your configuration file. This might be your model.yaml for GPT-2, for example, is what we're seeing here. And in it, you might have specified that your hidden size is such, and that you want to use rotary position, embeddings, which is the case in Llama models, right? This is what it looks like in the actual config class, right? So hidden size is how it's specified here. You can see that it's here. It's a data class in Python, which means it's now validating that this is an int, right? And then you can also do additional validation on the bounds of this. How large is it? How small is it? And then similarly, now you can see for position embedding type, we can have a series of options here between learned, rotary, so on and so forth, fixed, right? Depending on different papers that you want to try out for this model, and different types of embeddings. And then what's further interesting here is that for position embeddings that are of type rotary, if you've not specified an additional parameter called rotary dim, you'll see in my config here, I have not specified that the dimensions are X, right? We automatically set that as part of the config class. So you can also already see how cross-parameter kind of collaboration and creation is managed directly in the class. Now, I just want to reiterate here, this is not something you have to do. All of the models that are in Model Zoo have their own config classes built in. You can inspect them, you can see how they work. And then if you create a new model that you want to work with Model Zoo, or you port a new model over from Hugging Face, for example, then you can actually build a config class yourself to reinforce some of these elements and match them between the actual parameters and the classes. So that's one new thing that's being released in 2.2.1 is robust support for validation and things like that with config classes. And of course, if you want more information in the previous slide, you can click here and get a full review in our dev site. Kind of moving on to the next thing, one big kind of piece of functionality that's becoming available in 2.2.1 is just a vastly more performant way of pre-processing data. As we all know, when you're training a model, one of the key steps is getting your data, wrangling it, and making sure that it's in a format that the model can accept. We have a bunch of pre-built preprocessors that allow you to do this. And with 2.2.1, these are now much more performant across 3 different ways of sort of thinking about it. The first is that there's a built-in concurrency. So instead of using just a single process, we're using multi-threaded processes to actually run the processing much faster. As part of that, we're also introducing fault tolerance. So as we're doing data preprocessing, these can sometimes be lengthy runs where you're preprocessing data that's many gigabytes, many terabytes, and it's a shame when that run doesn't go as you'd like and you have to restart. So with this new form of data preprocessing that's chunk-based, we also now have support for fault tolerance. We're in the middle of this preprocessing job. We are going to be saving checkpoints as well, so you can restart data preprocessing from a previously stored checkpoint. And then last but not least, visualization is key to understanding how much time is left, what's going on in my pipeline, how far am I way through processing all my data. So we're now including built-in progress tracking as well. In our data preprocessing, what you can do, just to reiterate, is process data both locally as well as coming from Hugging Face or some other data source. And we have a built-in token generators for a number of different tasks. So for language modeling, there's a specific type of data preprocessor you might use. For summarization tasks, and when you're doing instruction fine-tuning, there's different data preprocessors that you can use. We also have support for VSL or variable sequence length. Now, again, all of this is documented. So if I'm going a little bit fast, it's okay. You can find all this information in our dev site. And in fact, let's go ahead and do that. If I click here, we'll see where this is in our dev site. You can see the information about the different types of data preprocessors you can use, the different support for training methodology, fill in the middle, variable sequence length, and sequence packing. And then, of course, there's a DPO data preprocessor as well for training DPO specific models. Lots of information here that I encourage you all to check out, and do kind of dig through the rest of our docs as well. There's a lot of information on what format of data to provide, how to access local data sets, and then of course, how to use the data preprocessors for specific tasks like pre-training or fine-tuning your models. All right, and one last note on this, data preprocessing, just like model training, is configured using configuration files, right, YAML files. So there's a lot of documentation as well in our dev site about which config, how to set up the config files. There's lots of example reference config files as well for different data sets and built-in data sets as well. So a lot of support there to understand what are the knobs I can tweak, what are the ways in which I can pre-process my data and get it quickly in an HDF5 format. That's the format that our models take for efficient training. Great. All right. The other big change in Model Zoo, and this is for those of you coming new to our system, this is going to be less relevant, but those of you that are coming from our previous versions of Model Zoo, this is going to be a welcome change as you get to see the updates to our organizational structure. So I'll linger on this briefly because I do think it's important to mention. that Model Zoo now looks slightly different than it did before. Before, we had data preprocessing inside the individual transformers folder, and then we had separate data preprocessing inside Vision. We renamed these sections to be a little bit more intuitive. Now, transformers is renamed to NLP. Vision, it stays inside Vision. All of these different types of models are now sort of folded on inside of our models folder, and data preparation is sort of brought out as a first-class citizen outside. All this to say that the organization of Model Zoo is a big factor in the usability of our entire Model Zoo infrastructure, right? And so this is an area of focus for us. You'll see continuous iterations to this over subsequent releases as well, as we fine-tune and hone in improvements to the structure. Where possible, we'll be very careful about backwards compatibility and give you a lot of updates on what's changing and where that's changing. And again, to get more data on this, you can go check out our docs, which give you a full detail about what's changed, what's moved where, and how this new format is easier to access different models and model configs for training. Okay, doing a little time check on myself. I have to keep things going. I'll mention briefly here that we do have support for a model registry in 2.2.1. This is where you can very easily look at what models are available. Once you've cloned Model Zoo, you can do registry_cli.py and run any of these following commands. Again, there's more documentation on all this to figure out what losses are available, what models are available as part of Model Zoo, what does a model look like, getting access to the README, understanding what you can and can't do. So a nice, easy utility to understand the layout of Model Zoo a little bit better. Okay, this is one thing I do want to touch on, but we will get into a little bit more detail on this in tomorrow's session as well with some of the hands-on. One of the best ways, one of the sort of secret ways really that you can increase your effective batch size is to do gradient accumulation. Now, this is possible in 2.2.1. You can do it in a very performant way using microbatching, and there's a lot of documentation on this. But in general, there's a couple of important points I do want to point out, which is that gradient accumulation, of course, increases training stability and allows the model to converge more confidently, takes larger steps because it sees more information, more batches, more examples per batch. The way to do microbatching, and again, we'll go into more details in a subsequent session, is to first set the microbatching parameter, and there's more details here in our docs if you're curious. Set it to auto when you're first doing a training run. And what this does is the system will automatically explore a relatively performant microbatch size that works for training, and it'll do your training run. The next time, once you've kind of done a few experimental runs, the goal is to then change it to explore mode, which is where the system, where the training run will actually explore a variety of different batch sizes to find the most performant one. But the most important point to remember is when you're done with all your experimentation, you found a good microbatch size using these different modes and these parameters, is to settle into the static mode, to not remain in automatic or explore mode, because that does increase your compile time. So that's one thing to remember as you're going through the process of exploring microbatching for gradient accumulation. All right, a few other important improvements to performance. We now have support for a more performant way of doing attention, which is the sliding window. Attention, as we all know, transformers have a quadratic complexity. So as the input size increases, the input sequence length increases, the size and time and memory requirements also increase with n squared. The sliding window attention, similar to computer vision, has a local receptive field of attention that is layered on top, increasing the effective receptive field over subsequent iterations. Long story short, this allows us to have robust attention while increasing the amount of context window and lengths and train larger models with more performance. Another kind of improvement in 2.2.1 is the ability to use position interpolation. The quick note on this is that it allows us to extend LLMs that have been trained on shorter context windows to process longer context windows beyond their original pre-trained lengths. And the way you do this is simply, again, all this, including the sliding window attention, as well as position interpolation, is managed inside your model config YAML file. And here's an example how you might do that. It can drastically increase the performance of LLMs on longer context windows, especially for models that are trained with rotary position embeddings like llama models. So this is a key improvement that's now available in 2.2.1. There's also some improvements to our sparsity API. Training with sparse models is incredible. Lowers the amount of flops. It's less memory to store on system, increased performance, reduced model size, and generalizability. Lots of wonderful reasons to check out sparsity. You can do that in our docs, and there's now a much easier API as well to access and train with sparse weights. All right, a last couple of things in the last 60 seconds or so that I have here. I want to mention that there's a train and eval mode that you can use as part of training. So when you do a training run, you can either specify to train mode, train and eval mode, or eval mode. The train and eval mode allows you to specify frequencies at which you want to do evaluations on your validation data set. And so you can set the eval frequency as well as the number of steps you'd like that eval to run on. There's more information here in our documentation that gives you examples. For example, if you set eval frequency to 5, you're going to run an evaluation every 5 steps. You can interleave this with the number of times you want to take a checkpoint and save the outputs of your training so you don't lose the state of your training. So a lot of flexibility and adaptability here in this training loop, in this workflow. We do have support for evaluation harness from Luther AI. This is a very popular way of evaluating LLMs on downstream tasks and data sets. And we have robust support for the Luther harness here as well in 2.2.1. You can kind of see how that's done. This is the script that you would use. Here's some parameters that you would pass in. You can also set these parameters in your model config file as well, or rather in your in sort of a configuration file that you would pass into this script. And there's more data as well in our docs. Last but not least, I want to mention just a minor point on checkpoints. When you're saving your checkpoint, there's often the requirement to save a lot of additional information, things like the location of your configuration files, your YAML files. What type of checkpoint is this? What type of experiment am I running? What tokenizer did I use? How many tokens am I training on? Where's the data set located? These are all things that you can now save in your checkpoint as part of the save checkpoint script. You can again click here to learn more, to see where that is exactly in the run CS-torch flow. You can see there's a section where you can add things to your state dict. This is your checkpoint dictionary where you can store anything that you like and then access it later as you're looking at your checkpoint folder. All right, so let me stop there and see if there's any questions. I'm a few minutes over here, so I understand that people have to run, but let me pause here for any questions on 2.2.1.